Hello everyone and welcome to Everyday JavaScript. In this video we are going to continue with the part 4 of this series, JavaScript the hard parts. We are going to talk about generalized functions. Pretty vague topic, right? So we are going to lay the foundation for our functional programming over here. From this video onwards we are going to lay some basic foundations about higher order functions, and we are just going to start dig the big hole of the functional programming in JavaScript. So let's get started. So if you guys are not aware about this, we have a channel named Everyday JavaScript and we are almost a community of more than 1400 people. So if you like the content, do press the subscribe button and do press the bell icon to get the notifications for every video that I upload. So today we are going to talk something cool part about functional programming, and we are going to start with something really basic, that is functions. What are actually the functions? Why do we actually need functions? And the main question, why do we even have functions over here? So we are going to talk about all of this inside this video, and I'm going to present you a challenge which would be quite irritating to you, to write such simple functions which may even make you pull your hair off your head. But don't do that. In the end we are going to reach to a conclusion where we are going to know why we actually need functions and why do we actually need generalized functions, and from there we would be able to jump onto higher order function. So we are going to answer the question, why do we even have functions? So I'll give you a problem statement over here. Let me switch to my drawing board as well, but I'll show you the problem statement first. We have to write a function 10 squared that takes no input and returns 10 into 10. Pretty simple function, right? Very simple function. I'll switch to my drawing board. So we have to write a function 10 squared which takes no input and we have to return 10 into 10. So let's get started. JavaScript, how do you write a function? With a function keyword. Right? And we have to associate a name to a function. So let me name it 10 squared. Now, does it take any input? The second point, it takes no input. So we don't have anything that is passed over here. We don't have anything that is being passed as a parameter. So we don't have any parameter getting passed. Hence we are not having any input. Next thing, it returns 10 into 10. Right? So if I basically execute this function 10 squared, how does JavaScript know that we have to execute this function? We have two round braces after the name of the function and a semicolon. So that's how JavaScript knows that we have to execute the function. The output of this would be simple 100. We know basic maths over here, and this is the easiest form of multiplication, 10 into 10, that we used to remember when we were small. So it will return us 100, right? I see the disappointment on your face. It's a shit function. It's a very crappy function. It's not supposed to be used, and it's not supposed to be written inside your application wherever you're writing, wherever you're learning the code. But lays a foundation, 10 squared. Next challenge. Write a function which is 9 squared and it takes no input and returns 9 into 9. So I won't rub it off entirely, but I'm just showing you what would the function be. You would write 9 squared We have written a function named 9 squared and it returns, it takes no input, so same situation, no parameters over here, and it returns 9 into 9. So we'll get the output when we execute the function 9 squared as 81. Correct? That's another shit function. So what if someone asked you to write 8 squared, someone asked you to write 7 squared, someone asked you to write 125 squared, 200 squared? You would say, I'm not going to write such unmaintainable and non-reusable code over here. What principle, what basic coding principle are you violating over here? By writing 10 squared, by writing 9 squared, 8 squared, 7 squared, 150, 125 squared, 200 squared, what principle are you violating over here? Do not repeat yourself. The dry principle of code. We are breaking over here the DRY, the fundamental principle which asks us to write as minimal code as possible so that it's maintainable, so that it's reusable. And that's where we are breaking the principle of DRY, where we are writing all these functions which at later point of time become unmaintainable if I had to change the function's logic. Although it will remain the same, but it's not maintainable having 100 functions for 100 different number. So we have to write as little as possible in DRY. And I don't mean least number of coding words per hour per amount of money you make, but something that's more logical, something that's more sensible, something that's more reusable and maintainable. So we have to write that over here. So what happens if we write that kind of code inside our application? We are reducing the trackability of our code. We are reducing the maintainability of our code. And that's where the problem lies. We have to write and we have to be following the DRY principle where we are increasing our trackability and where we are increasing our maintainability if we write DRY code. So always write a code which is trackable, always write a code which is maintainable, and that's where it will help us maintain the DRY principle. Now, what can we do instead? What can we do of this mess? We have function 10 squared, we have function 9 squared, we have function 8 squared. What is common? Squared, right? The squared functionality is common. And the number that we are multiplying with each other is common because it's a squared logic, right? So it's 10 into 10, 9 into 9, 8 into 8. And whatever number that we are providing to the function is common. So what all is common amongst these functions is squaring is the same, and we just have to generalize the input. It's 10 into 10, 9 into 9, 8 into 8, 7 into 7, blah blah blah, n into n basically. So we have to generalize the input, that's all we need to remember. And by generalizing the input, we make the function more reusable. How can we do that? So we are going to write a function square num and it will take in a parameter over here. We are going to say that parameter name is num, and it will return num into num. So basically it takes in a parameter num and returns you num into num. Now what happens inside JavaScript is, you might have seen our previous diagram which says that if you are writing a function, it takes this piece of code and saves it inside the memory as a string. Same thing is happening over here. You're saying take square num function and leave certain bit of code, that is num inside our case, leave the data part of that function to be decided at a later point of time. So what we are doing over here is we are having square num function with small amount of data which will be decided at a point of time when the square num is getting executed. That's where the concept of parameter and arguments of functions come into picture. So as soon as when we execute this function, square num with a parameter of 10, what happens is this 10 will be decided only when this function is the value of num will be decided only when the function is getting executed, and the value of num at the point of execution in that current execution thread is 10. And at that point of time we get the return of 10 into 10 as 100. So we are giving the JavaScript the freedom to decide a little bit of data only during the time of execution. It need not have the data right at the time and place where the code starts executing. So like let's say if we are on line 1 and we don't need what num's value is. We don't need to know what num's value is. We just need to know that value of num would be 10 whenever the function is getting executed with an argument of 10. We know that value of num would be 9 when the function is getting executed with an argument of 9. So what we have achieved over here, we have written the function once, the square num function. We have reused it multiple times. Square num with an argument of 10, square num with an argument of 9, square num with an argument of 8, 7, 125, etc. etc. with different data 10, 9, 8, 7, 125, 200, etc. etc. That's what the core use of functions is, right? Functions. It's a function. It's a set of tasks which can be executed whenever we require. And those tasks remain the same. You just need to configure it with a certain kind of data. So that's where the parameters are coming into picture. So the num that you saw is a parameter. Parameters are the placeholder. Just as I said, we left a certain piece of code to be decided. Means we don't need to decide what data to run our functionality on until we actually run the function. So until JavaScript encounters square num 10, it does not know the value of num is 10. Until we execute the function square num with value 9, it does not know what the value of num is. So parameters are the placeholder and they are the prime responsible thing over here to make the functions generalized. But what if we can leave a little bit of our code to be TBD? That would be awesome. That would make our functions super reusable and super generalized. And that's where higher order functions come into picture. And that is going to be our next video in this series. And if you have any questions, do post it in the comment section. Please do like, subscribe and share this video with your friends. And thank you for watching Everyday JavaScript.